I was writing this Python data script the other day, just a basic data crunching task, and I hit run, and I kid you not, I had enough time to brew a whole pot of coffee,
Oh, yeah.
fold a massive load of laundry,
Right.
and basically sit on the couch contemplating the vast wonders of the universe before the script finally finished. It is a very relatable experience if you write code. But in this deep dive into our sources, you are going to discover a brilliant, highly optimistic trend taking over in 2025 and 2026. Python developers are supercharging their code by learning Rust.
It's a well, it's a fascinating evolution. We're watching developers intentionally expand their toolkits, merging the strengths of two radically different ecosystems to build faster, incredibly reliable technology for the future.
Okay, so let's unpack this. Python is beautiful. It has this simple, readable syntax, and it absolutely dominates fields like AI and machine learning.
It really does.
Actually, speaking of AI, if you are looking to integrate those kinds of tools, this podcast is sponsored by Silk. Need help with AI training or automation or integration or software development? Uncovering where agents could make the most impact for your business or personal life. Check out embersilk.com for AI needs. But getting back to Python, despite its dominance, it has a technical ceiling. You eventually run into constraints like the global interpreter lock.
Ah, the notorious GIL.
Right, the GIL, which basically acts like a strict traffic cop. It only lets one thread execute Python code at a time. It makes processing mountains of data quite slow.
Right, and what's fascinating here is Rust's superpower. Rust is a systems programming language that offers C++ level speed, but it comes with strict compile time memory safety.
Oh, it's huge.
It is. It completely eliminates things like data races, where two parts of your program try to change the same data simultaneously, and memory leaks, where a program forgets to free up memory it's no longer using. And it achieves all of this without needing a garbage collector.
Right, which is essentially an automated cleanup crew that runs in the background and slows things down. But here's where it gets really interesting. This trend isn't a competition to see which language wins. It is a hybrid model.
Exactly.
Python remains the highly intuitive glue holding the application together, while Rust steps in behind the scenes to do the heavy lifting.
Though Glue almost undersells it. Python acts as the highly accessible user interface that keeps developers sane, while tools like Pyo3 and Maturin act as seamless translators. These utilities let developers write native, blazingly fast Rust code and package it as a standard Python module.
So if you're a Python developer, you just type an import command like you would with any pure Python package.
Yes, but you're actually running a hyper-optimized Rust engine at the system level.
So what did this actually look like in practice? Are we talking about a minor efficiency bump for the end user?
It's far from minor. Take the data validation library PydanticCore. By rebuilding its core logic in Rust, it became 17 times faster.
Wow, 17.
Yeah, or look at the RoughLinter, which achieved 10 to 100 times speedups. We are talking about massive amounts of time and computing energy saved simply by using Rust where it counts.
If we're seeing that kind of rock-solid reliability in everyday data tools, it makes perfect sense that engineers would want to use this hybrid approach for higher-stakes hardware.
Right? If we connect this to the bigger picture, absolutely. The reliability proven in those software libraries is giving engineers the confidence to push boundaries in the physical world. Through initiatives like the Safety Critical Rust Consortium, which partners with tech leaders like ARM and Toyota, developers are safely building embedded systems for highly sensitive fields.
Like aerospace and medical devices.
Precisely. They are perfectly blending Python's ease of use for high-level logic with Rust's fail-safe guarantees for the hardware.
It's incredibly uplifting to see the tech community collaborating like this, building better, safer infrastructure that will drive human progress forward. So, what does this all mean for you? I'll leave you with this to ponder. What if the future of technological innovation isn't about finding one single perfect tool, but building harmonious ecosystems where different tools beautifully cover each other's blind spots?
That is the big takeaway.
If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.